Namaskar, my dear friends. Let us design and simulate some circuits using Zener diode. So what we'll do is we'll try to use Zener diode as voltage regulators and we'll see how to simulate circuit, and this Zener diode helps us to clamp the output voltage. V out is going to be Vz based on the fact that my load resistance value, like load resistance voltage, that is always greater than Vz. Okay, so that we have already understood in our previous sessions. Like this was the theory about Zener circuits. What was that is, we have a input voltage, we have a series resistance, that is our source resistance you can say, and then we have a load resistance. This Vz, that is the Zener diode, is going to regulate the output to Vz value. Okay, so let us say this is my 6 volt and we want our voltage to output to be 6 volt always, irrespective of the input voltage. So that's the reason. What was that? VRL was V input into RL by RL plus RS when Vz is off. Okay, so in that case we'll see my VRL is less than Vz, then Zener will be off, like it will not be in working condition. And this is how output will remain equal to your VRL which you calculated. But the case happens is when this VRL is going to be greater than Vz. Okay, this particular VRL you calculated is more than Vz, then Vz becomes, comes into picture, and this Zener diode becomes on, and in that case output will be regulated to Vz, and in that case the current IL will be equal to Vz by RL. The voltage will be Vz, so Vz by RL will be the load current, and similar to that, what will be the current flowing through IZ, flowing through this Zener diode, that is IZ, can be very easily calculated, because this current will be equal to sum of this current plus this current. Okay, so this is how Is will be equal to Iz plus IL, and Is is very easy to find. Is, the source current, will be equal to what? Input voltage minus Vz divided by Rs. So V input minus Vz divided by Rs. So this is the way you have found out your IL, you have found out your Is, and this is how Iz will also be found out. So why don't we do some simulation and then we'll see what is happening. So let us say we have a simple circuit. This is input is 9 volt and 50 ohm, and this is 1 kilo ohm. So you can see this is my 5.6 volt Zener diode. So what is going to happen is the input voltage, you can see it is 9 volt, and the output voltage is regulated to 5.6 volt. Understood? So you can see that the voltage at this particular probe PR1 is regulated to be equal to 5.6 volt. You can see here 5.65 it is written, because the simulated components are little bit deviating, so you don't have to worry about this. However, let us open multisim and try to simulate this circuit and see what is the result. Okay, all right, so this is the circuit that I have R1 and VZ with this particular value 5.6 ohm, 5.6 volt, and this is my load resistor R1. Okay. Now if we simulate this, all the voltages and currents are appearing in this. Instead of that, what we can do is we can go and analyze simulation and then come to transients. Let us say I'm going to run it for this much second only, not a problem. So you can see we have this particular, let me remove the currents. Okay, I don't want to find currents, and trace width, if I increase, you will be able to see it much nicely. Okay, so you can see my probe 5. So probe 5 is nothing but the input. You can see probe 5, right? And then probe 1 is nothing but your output voltage. So that is going to be clamped to 5.6 volt. Understood? So this is the way you can see that. If you want, you can enable the grid so that it is much easier to view. Let us open another circuit and see what happens. Or why don't we do one thing? Let us change this voltage to 4 volt. So since it is 4 volt, which is less than VZ, like if you calculate RL, it will be lesser than that. So in that case, the voltage at this node will be following the simple voltage division principle what we studied, okay? And VZ will not come into picture. That Zener diode will not come into picture. So you can see the output voltage is 3 point, like 81 or 82 volt. If you calculate, you will get 3.82 volt or something, and the input is 4 volt. So this is how it works. Let us open another circuit and see what happens. So I have one circuit which you can see, the Zener diode is placed like this. Okay. So this will be in breakdown, then only it will allow this particular input to pass. So I have taken a 1 kilohertz 12 volt peak source. This is my AC source. How to get this? Very simple. Go to component, go to sources, power source, no, signal voltage sources and AC voltage. So this is how you get the source, and you change the voltage peak to, let us say, 12 volt. Now whenever this will go more than 6.2 volt, then only it will be in short circuit condition, and this 6.2 volt will be clamped. So the maximum voltage that it can reach to is 12 minus 6.2, that is 5.8. So 5.8 will be the, like voltage at this point whenever it is more than 6.2. Okay, this is how it works. So let us run and see. So as you can see, my red color is your input voltage, okay? And green color is your output voltage. So what is going to happen? Whenever whenever this is the input voltage, 12 volt peak and 12 volt down, right? And whenever it goes like this Zener diode, it reaches to 6.2. No, it's not 6.2, because 12 minus 6.2, that is 5.8. So it reaches to 5.8 and then comes down. And negative side, it is, like short circuits. That's the reason what will happen? It will be complete path following, not a problem at all. The deviation that is there because of the forward biased voltage, which will be 0.7 volt. So 0.7 volt drop will be there in the negative side. That's it. Let us take another circuit. Okay, so this is the circuit that is there. So my input voltage is, let us say, 10 volt, and what I have done is I have taken the Zener diode which is IN749A, so whose VZ is 4.3 volt. Okay, so this 4.3 volt, what will happen? From this direction, whenever it is positive, this will be having a drop of 0.7 volt, and this will be dropped up to 4.3 volt. Okay, so let us say how it works. If I run it, you are going to see that the voltage regulation is happening from both direction. Okay, so it will go like this. So how much there will be drop? 4.7 plus zero point 0.7, that is around 4.3 plus zero point 0.7, that is 5 volt. So it is reaching to 5 volt positive, and the negative way, in negative cycle, it will be going to minus 5 volt. Understood? So plus 5 minus 5, it is clipped, and after that you can see it is not going. So the output voltage at PR2 will be limited to plus 5 and minus 5 by the Zener configuration which we have done. Okay. Let us take another question. If you want to put the Zener diodes, what you can always do is you have the choice of Zeners. Okay. Let me show it to you. So as you can see, we have a Zener diodes. So this is the series 1N4, or 1N7, 1N437, or 1N7475. Okay. So all these are having proper Zener voltage. Okay. So this is the, symbols that is available in NI Multisim. So any of the Zener diode that you want to use, you can use for 3.3 volt, 3.6 volt, 3.9 volt, like that. Whichever the number that is given, that only you can take and you can start with. All right. There are more Zener diodes, not a problem. I'll show you in the Zener diode, place components. Go to place components. Come here in diodes. We have Zener diodes. And here we have 1N4744. So 1N4744 is what? Let me just put it here. And and just check 1N4744 will be, what will be the voltage. So 1N4744 is not there here. You have to go to, like DG key and find out the voltage. Okay. Yes, so 1N4744 is actually 15 volt. So this 15 volt it will regulate and it will give you the results. Okay, so if you want, you can quickly, switch. I mean, simulate this as well. So let us say I am going to make a circuit like this. Very simple circuit. So with this Zener diode, this will be regulating at 15 volts. So I'll just make this as, like let us say 20 volt peak to peak. Okay. 1 kilohertz you can reduce if you want, but let it be. It is anyway simulation, so not a problem. Okay. And this is the way you can, like simulate the circuit for Zener diodes. Okay. And your aim is to, you must make sure that the voltage at this point should be in such a manner that output voltage is greater than this 15 volt. So Vz is actually 15 volt for this. So let me just write it here so that you can always have a clear picture in this. Okay. Yes. Now if you run it, what will happen? If you see R1 and R3 and R2, then it is going to give you 15 volt. Sorry, 10 volts. It will not matter. So what I'm going to do is, let us say this is my output and this is my input. And let's run it. So you can see it is not regulating. It is 15 volt. Sorry, it is 10 volt. The green color, which is the output, which is 10 volts. That's the reason it is not on. Okay. Now, if you want to make it on, your aim is the voltage at this node must be more than 15. Okay. So let us say I'm going to make it 50 volt. Okay. 50 volt. So what will happen? 50 by 2, that is 25 volt. So 25 will come here, but the thing is Zener diode will be in picture and it will limited to 15 volts. So let us run it. So you can see input voltage is 50, but output voltage is clipped to 15. Okay. Input voltage maximum is 50, and input voltage is clipped to 15. As soon as it goes up, it will clip. And in other direction, it is going to 0. Why? Because it will be short circuited, like forward bias. So in negative cycle, it will be moving like this. Okay. Let us quickly see another circuits. So I am going to open next circuit of Zener diode, let us say 4. Okay. So this is the circuit that is there with us. This is the circuit that is there with us. And as you can see, we have 1 kilo ohm and we have 3 kilo ohm. So the voltage at this point is, this is 5.6 volt. Okay. So voltage at this point is 5.3 because the calculation is less. Okay. 5.4 or something. So if you simulate, you are going to get 5.3. Forget this graph right now. Now, if you want to see in graph, what you can do, go to simulate, analyze, let us say transient, and run it. So graph will come here, and since this is a DC voltage, so DC voltage is coming. So I'll just remove the currents and I will just make the trace width, let us say little thicker, and this is limited to this point. Okay. So it's all up to you, like how do you design the circuit and simulate the circuit. Let me just open last circuit so that you can have a proper understanding of complete Zener circuit. Okay. So we have here 10 volt. We have here 10 volt. Now what is going to happen? Whenever the voltage will be more than 10, this will clip. Okay. But at the same time, we have a biasing of 4 volt here in opposite direction. Okay. So what is the result? What I have put is AC voltage 15 volt peak to peak 1 kilohertz. We have a series resistance at this input, and then we have output resistance which is going to be load, that is this much. However, we have one diode which is biased by this 4 volt reversed biased, and this is the Zener diode that is going to be 10 volt. So what is going to happen is, Let us run it, and you can see this is going to regulate both side with little bit of shift. So the red color is your input signal, the red color is your input signal, and the green color is your output signal. Understood? So this has been, actually it should have regulated to 10 volt because of this Zener, but this 4 volt is making sure little more, so that's the reason it is still reducing to 5 volt. Okay, so like 4 plus zero point 0.7, that is 4.7. It means almost 4, like this is also 4.7 or something. Okay, just less than 5 volt. So this is how you simulate the circuit and check your different understanding. So what you can do is, as a task you can try to simulate this circuit, and as well as you can try to find out by yourself what is going to happen if I put a diode like this and put the Zener diode with 10 volt like this. Okay, then it will regulate both side, like this one, the green one. So if you want to calculate, you can do that calculation and you can see whether it is going to do this or not. Okay, alright guys, thank you.